Imagine you are living tens of thousands of years ago. No cities, no laws, no doctors, and your entire tribe consists of only about 30 people. Then one day, you must find a mate. You look around. But there is a terrifying problem. Almost everyone you could choose is already a relative. If close relatives kept having children together, harmful genetic mutations could accumulate and threaten the entire community. So why didn't ancient humans simply trap themselves in a genetic dead end? The answer lies behind three invisible lines of defense. But the first line of defense was not a law carved into stone. It was already inside the human brain. Anthropologist Edvard Westermark proposed a fascinating idea. Children who grow up closely together during their early years tend to develop a powerful psychological aversion to sexual relationships with one another later in life. In other words, the brain may use childhood familiarity as a shortcut. This person grew up beside me. They are family. And remarkably, this mechanism does not necessarily depend on sharing the same genes. One of the most famous examples comes from the Israeli kibbutzim, where children were often raised together in age-based groups. Researchers later examined thousands of marriages and found an extraordinary pattern. Couples who had been raised together during early childhood almost never married one another. Think about what that means. Even without understanding DNA, genetics, or inherited disease, humans may have possessed a biological mechanism that helped reduce the chance of mating with those who felt like siblings. And the story becomes even more fascinating when we consider another possible layer: our sense of smell. Some research suggests that humans may respond to body odors influenced by immune system genes known as MHC, potentially affecting attraction and genetic compatibility. The ancient human brain did not understand genetics. But perhaps it didn't need to. It simply needed to recognize one thing: some people feel like family. And that instinct may have quietly protected generations from the dangers of inbreeding. But instinct alone was never enough. Ancient societies needed something even more powerful: a rule that everyone could understand. Instinct could help keep close childhood companions apart. But ancient humans needed another layer of protection. They needed rules. Across many human societies, marriage was never simply a private choice between two individuals. It was part of a larger social system designed to determine who could marry whom, and sometimes who was completely forbidden to marry. Some societies divided themselves into two major groups, known as moieties. A person could not simply choose someone from their own group. Marriage was expected to occur with someone from the other half. And in some indigenous Australian societies, these systems became remarkably complex. People could belong to specific social categories from birth, with carefully defined marriage partners and forbidden relationships. What looks complicated to us may have served a very practical purpose: preventing repeated mating between close relatives while connecting different family lines. These rules were reinforced by something even more powerful than genetics: social consequences. Breaking marriage rules could lead to shame, punishment, or even expulsion from the community. In a prehistoric world, where survival depended heavily on cooperation, being cast out could be devastating. Imagine losing access to your relatives, your shelter, your food-sharing network, and the people who would protect you. The punishment itself became part of the defense system. But there was a deeper principle underneath all of this. Ancient humans did not need to understand chromosomes to discover that a small, isolated group could not survive indefinitely by reproducing only within itself. They needed outsiders. They needed new families. And eventually, they needed something even bigger than marriage rules: a network connecting one small community to another. This was the third and perhaps most powerful defense. Ancient human groups were small, but they were rarely completely isolated. A band of a few dozen people could be connected to dozens of other families spread across a much larger landscape. At certain times of the year, different groups could gather, exchange food and tools, share information, perform rituals, and, importantly, form new relationships. Think of it as a prehistoric social network. A young man did not necessarily have to choose a partner from the few people living around his own camp. He might meet someone from another group several days, or even much farther away. These gatherings transformed a collection of tiny populations into something much larger. And archaeology gives us clues that such connections really existed. Marine shells have been discovered hundreds of kilometers inland, far from the coast where they originated. Rare stones and other materials also traveled enormous distances through prehistoric landscapes. These objects did not move by themselves. They were carried, exchanged, gifted, and passed from person to person. And the same networks that moved shells, stone, pigments, and ornaments could also move something far more important: people. A marriage between members of different groups could introduce new genetic variation into a small community, reducing the danger of repeated close relative mating. In this sense, ancient trade routes were more than economic pathways. They were also biological pathways. Every new visitor, every distant marriage, and every social gathering could bring fresh genes into a vulnerable population. But how do we know these networks actually prevented inbreeding? One extraordinary archaeological site provides a remarkable clue. Its name is Sunhir. One of the most fascinating clues comes from Sunhir, a 34,000-year-old Upper Paleolithic site in Russia. Researchers studied the DNA of several individuals buried there, including 2 children placed head-to-head beneath thousands of ivory beads. You might expect people living in such a small prehistoric population to be closely related. But the genetic evidence tells a different story. The individuals were not close relatives. Their community appears to have maintained surprisingly wide social connections, helping prevent severe inbreeding. Now compare this with some Neanderthal populations. Genetic evidence suggests that certain Neanderthal groups were extremely small and isolated, sometimes resulting in close relative mating. Their problem may not simply have been their biology. It may have been isolation. While Homo sapiens increasingly maintained connections across distant communities, some Neanderthal groups became trapped in small populations. And once a population becomes too isolated, genetics can become a dangerous trap. The lesson is striking. Survival was not only about strength, it was also about connection. 3 forces protected ancient humans from the dangers of inbreeding: instinct, cultural rules, and connections between groups. But these were more than reproductive safeguards. They encouraged humans to trust outsiders, exchange resources, share knowledge, and build alliances. A small tribe could survive because it was never truly alone. And that may have been one of humanity's greatest evolutionary advantages. We survived not simply by becoming stronger, but by becoming connected. Thousands of years ago, our ancestors had no knowledge of DNA, yet instinct, cultural rules, and social networks helped them avoid the genetic dangers of isolation. Those same connections eventually became the foundation for something much greater: cooperation, trade, shared knowledge, and civilization. Perhaps the greatest lesson is this: human survival was never just about surviving alone. It was about connecting with others.